This video shows you how to measure the focal length of a biconcave lens. I have a ray box set up with 3 parallel rays of light emerging from the ray box. I'm now going to put a biconcave lens in the path of the rays of light. You can see that the rays of light are now diverging. The next step is to pick up a pen and make some markings. First of all, where the rays of light emerge from the ray box, where the rays of light enter the lens, where they exit the lens, and further along the rays as well. We can also trace around the shape of the lens. That will look neater on your diagrams because you'll be able to use the actual lens to trace. After you've done this, what you can then do is to remove the ray box, and the next diagram will show you what it should look like. Okay, that's what it looks like. What I'm going to do next is to use a ruler to trace over all of these lines to make it look a whole lot neater. Okay, I've now traced over the rays of light, and the last construction line that I need to add in is I've now placed a ruler that goes straight down the middle of where the lens used to be, and I'm now just going to draw a dotted line along that ruler. So the dotted line goes straight through the middle of the lens. Now for the tricky part, what I'm going to do is I'm going to use a ruler to extend the lines. These lines over here, I'm going to extend them in front of the lens. Okay, so the orange lines are the orange dotted lines are an extension of the blue lines. I'm going to do that for all 3 rays of light. Okay, I've extended all 3 rays of light. My diagram is not particularly accurate. They should all be meeting together at a point, but hopefully your diagram will be more accurate. Now we're ready to measure the focal length. The focal length for a biconcave lens is going to be the distance between where these extended rays of light meet. Okay, so this point over here and the midpoint of the lens. So in this case, the focal length of this lens is about 3.6 centimeters.